Good morning, good evening, whatever suits your time zone. Today I'll be talking about how threat actors abuse cloud services. My name is Maciej Kotowicz. I work as a malware researcher in malwarelab.pl, where I'm trying to help people with their malware problems. So if you have any, don't hesitate to reach out. Maybe we can help. Besides working with malware, I'm doing various projects and play CTFs with Dragon Sector. And that will be enough about me. Let's begin our journey. Um, so let's start with some ideas at where and when we can use cloud services. So this is the picture most of you probably are familiar with, named kill chain, infection chain, whatever you wanna, whichever name you prefer. Um, it's a basic list of steps, basically list of steps you need to take, or you will take in order to successfully compromise a machine or whatever target is whatever is your target. And we have like those seven simple steps, right? Named reconnaissance, weaponization, delivery, exploitation, installation, command control, and finally doing some actions on an objective. Then they are pretty straightforward, right? Reconnaissance will be like gathering information about targets and um, what software they're using, what maybe names of documents are passing in, stuff like that. So whatever gives you enough information uh, to successfully influence your influence your delivery method. Weaponization will be like gathering some tools that will be needing to compromise target. Delivery, obviously, the way how we wanna um, deliver the malware or exploit or whatever itself. Mostly like will be spear phishing emails or watering hole attack, whatever. At the some sort of exploitation will be happening, like user clicking macros or whatnot. Later on, it will install some stuff. Some this stuff will call to C2 for commands or just saying, okay, it's there. What's next? And at the end, the attacker will do some actions on an objective. And in case of um, the most attackers, the most attackers who follow this chain, or somehow state sponsored, or have some concrete objective, that will be some sort of gathering data and exfiltration. Well, at least part of those actions will be exfiltration. And few of those steps are in few of those steps we can actually use some cloud services to help either stay under the radar or speed up preparation for attack or stuff like that, or just have a nice storage of data that will be untraceable, for example. Um, so I'm thinking about. I will try to show you in which steps actors can use cloud services, and later on I'll try to show you some examples of how what actors I found and well interesting actors I found, at least from my point of view. Um, I found using and abusing those methods. So first start with weaponization. Obviously, we can go, which is, as I said, a way of finding, creating some sort of exploits or malware. And the best source of that is basically, obviously open source if you want to stay under the radar. And today it's, I guess, kind of hot debate about if offensive research is good or not. So this is something I actually won't be talking about today. Just will mention it as one of the actors using it, but nothing more important, nothing there. And I'll talk a little bit more about delivery itself, delivery, as in this case, this step, um, actors can use cloud services, for example, for hosting their stuff, be it code, lures, whatever. But also that can use image of um, cloud providers and abuse this image to create some sort of trust relationship with a user they want to attack. So it will be more inclined to click on the link, for example. Um, and C2s, obviously, we can host just the regular C2s, like some crappy PHP scripts on various free hostings or various BaaS platform or whatever, but we can also use, and something that attackers start to using is creating some non-traditional C2s, like um, abusing or basically using some metadata of cloud service or files hosted on the cloud service itself to hide communication in plain sight. And at the end, as I said, the exfiltration is some sort of is one of the things that has to happen. So exfiltration is another place we can actually use cloud services, and one of the most like one of the obvious steps will be just to upload data to some cloud and hide the um, actual C2 exfiltration of data, because there will be a BANE request to the normal service. This concept I'll try to illustrate with a couple actors and a couple malwares and uh, one threat actor. Sorry. The first one will be Xdrive, then we'll go with Neural, which is a malware, and I will try to say why I believe it's operated by Gaza Gang, and then we'll go with Fishing Elephant, which is very funny actor, I think. And I'm not sure about anything being published about any of those besides the Fishing Elephant that I did a couple of conferences in the last couple of months. Okay, let's go. Xdrive. We'll go through whole infection chain, and I'll give you some nice pointers or what's going there. So it started as most of the attacks with some sort of spear phishing and document with macros and some sort of social engineering attempt to force user to click and run the macros. So you have like this document with enable content to decrypt, stuff, blah blah blah. Under there is a very simple macro, and that will download two files from Dropbox. And Dropbox is one of the services I will be mentioning actually quite a lot today. It seems to be like one of the go-to file hosting providers for threat actors, both crimeware and nation state APTs. What's not? But so it will download two files, and one will be MSI, and which is basically installer for exe, and the other will be BotScript. So pretty simple stuff. So let me try to show it to you. Right, so this is this simple script. It does basically runs the MSI. MSI will unpack to file exile.exe, and we have the malware. And the malware is actually interesting part. So it's actually a very simple one. It's validator /simple/rad downloader, whatever you want to name it. But it's like the first stage malware that will be dropped on a target in order to understand what happened, and if you can do anything funny with this compromised machine. So what will we do? It has like these four comments. It can download download file from the URL directly from bytes in comment, and write it to the file and then execute it. Take a screenshot and execute some comments. Um, the results will be uploaded to a hard-coded Google Drive for attacker to write to fetch it. And the actual C2 channel is very interesting, at least quite unusual for me. So what will happen at the beginning of the infection, the malware will fingerprint the machine, get some data about like the username, the computer name, some information about installed viruses, stuff like that, and we'll create a paste in a paste bin with those informations encoded, I think. So attacker can go there. Obviously, it's using some API key with some registered account, and so the attacker knows which account to follow. So he's like listing the new paste. If it happens, then the new paste came in, he will read it. If it's interesting, it will issue some comments to the malware by modifying the paste, which later will be read by the malware, decode, and the comments um, will be executed. So this gives you quite a nice. The whole infection chain looks pretty valid if you have only network defense. So there will be no suspicious traffic at all, no known C2 connects or what's not. So that's pretty nice way of bypassing the network defense. I only found like 2 or 3 free cases of this malware. So it's written in .NET, packed with some uh, customized maybe or something like that version of Confuser. So there's nothing super advanced, and there was no files on the drive, and the paste is already dead. But I don't know, like I never found more than this, which is kind of upsetting because I like that I like it how we create this attack. Well, on to the next one. This one actually has some backstory, and the backstory goes like that. Beginning of the year, there was research published by Talos about drone rat, and it was a new Python rat that they found, and they describe it in details. It was a very nice blog. You should definitely read it if you did not yet. And but I was working on this case actually at the same time, and they basic um, as they mentioned that they mentioned in their analysis that the document, well, probably everything started with this mofa.x document because it's something on everyone's watch list, I guess, um, being uploaded to VirusTotal, of course. And it's a very interesting document. It has the analysis of this is quite well. The malware itself is the document is quite nice. How they do infection, um, but it was unique enough so I can found like created some sort of signature and search for other stuff, and I found those couple documents. This is except from my notes back from beginning of the year, and the one we'll be talking about today is this one actually, 17-12-2019 .x, which was netrat, not Python. So that's something that stood up. So let's go with this story. Um, so it was in the same fashion. That was a file that has a remote content hosted on Google Drive. You can fetch it if you manage to fetch it. You'll get a document with a macro. Macro was pretty simple. Again, it will just call to the GitHub and download executable that will be later run or decoded from base64 and run. And the document is the file is not there, but you have the hash, and I think it's on the VirusTotal, so you can find it later on. The malware was pretty simple. It's a first stage validator again. Fingerprints machine downloads files and execute commands like every validator. But it has a little bit more into it. It has a very nice C2 channel. So they create a very nice C2 channel, which is, and in the way I actually didn't think about. And it's the first time I saw something like that. So let's go with about that. Sorry. So what they did, they created a channel that was based on the files from Google Drive. When the bot get start infection, it will create a directory on a Google Drive um, with a bot ID. Like the name of the directory was the bot ID, and under this directory there will be created a bunch of different files with a specific MIME type, and it will be searching through this drive for different MIME types in order to understand what commands were issued to him, to the bot. Um, MIME, and we have like a bunch of those MIME types with and there's some synchronization going on and possibility to download tools, information when the bot was last seen, everything that's basically needed to have a functioning C2 channel. But as I said, it's quite unique to use MIME types, not the files. So if you don't examine the files carefully, you have like just some pictures or whatever, but the whole magic is in the MIME types, which is quite nice. And I queried this Google Drive, see what's happening. It's still available, so you can get some files from there. Um, there were a bunch of tools. Most of them were Quasar, some packed, and some, yeah, mostly packed or obfuscated or whatnot, like typical Quasar stuff. Um, Nothing fancy there. There was some C2s, and C2s at some point turns out to be related to mole rats or Gaza Gang or whatever you want to call them. Um, but the most important at the time I was analyzing it was this file Google E, uh, which turns out to be an evolution of XGaza, which is a Kaspersky name for Spark. And this tool is uniquely attributed to Gaza Gang. So that's why I'm attributing this neural malware to Gaza or Morlats. Uh, and the name of the neural and the name of the previous one, the X drive, came from this kind of email address. You can see here. It's actually a login or user ID of the on the uh, Google Computing Engine that's created by attackers in order to use Google's API to interact with the services. Okay, the next one. Where's my mouse? The next one will be Fishing Elephant, and I will go through quickly with three their campaigns and the exfiltration method. Um, more of I'll try to be brief on that. More you can find on my talks about Fishing Elephant itself on different conferences. Okay, so the first campaign was quite unique. The one actually that caught my eye and make this kind of whole research possible because it looks interesting. It was a spearfishing emails with a fake link to a fake Google Drive, and under this link, like this docs dash op whatever, um, they hosted a simple HTML file that will be uh, they look like Google Drive download um, um, site, and and will redirect you if the user click download, that will be redirected to HTA script that will be responsible for getting malware and running malware on the drive, on the hard drive of the or whatever type of drive on the infected computer, and firing up the browser that will be uh, calling again to actual Google Drive in order to show the lure or the fake invoice in this case. Um, the campaign was about sending CVs, so they had like bunch of prepared bunch of CVs that they hosted on Google Drive, and it looked quite vague from point of from a viewpoint of being the one that's being attacked. So there was nothing suspicious, and the infection could go undetected. Mm, the payload was the link for the final payload was hinder under Bitly and sometimes others. The host payload was hosted on cloud storage services like Dropbox, Yandex.Disk, ASUS Web Storage, uh, and similar. And at the end, they dropped aaS-rat, which is a very simple Python rat that you can find in on GitHub. Second campaign, a little bit less fancy, I guess. It was just a document with maybe internal names and current events, but no, there was no fancy scheme like redirects to the fake Google Drive or whatnot. It was just a simple document in an email with DTE in order to fetch some batch script hosted on Dropbox and execute it. Later on, we'll get a VBS script, VB script that will get malware on our disk and run it. So in the same style, almost the same style as in the previous case. Um, there was no decoys in name in the documents. It was just a blank page. So this was kind of suspicious. Um, and they moved from PowerShell to bitsadmin for downloading and stayed again used Bitly for hindering uh, the final URLs and dropped aaS-rat as a final payload. The last modification in the campaign number 3, basically the same stuff as number 2, but there was an intermediary step added as that will do some geofencing. So if the request came from the country they are not interested in, the request will be redirected to the script that will start Windows update. If the country was of their interest, they will be redirected to other script that will basically do the same stuff as previously, which is download file from Dropbox. This time the file was actually the file of the binary was actually encoded with base64 and was mimicking um, certificate. So they can use certutil to decode it, and yeah. So if someone is not looking for it, they will be missed. They will miss the moment that they actually creating the executable on the disk. Okay. So those 3 campaigns, they were quite successful actually. I saw a lot of victims from it. Well, a lot in terms of target attacks, which is in quantity of tens, not hundreds. But I saw some victims. Um, so after some time, the victim will, if the victim was interesting, they will get this command that will download another 3 files from Dropbox, and 2 of those files were totally non-malicious. That will be system.exe and tmp.exe with the real names rclone.exe and 7z.exe. The first one is a compiled binary of rclone, and the second one is 7zip, obviously. And the rclone is actually a tool used for managing cloud disks. So like different storages. One of those would be Google Drive. So after this script on the top, the victim will get the second script, and the script will basically iterate over interesting files, pack them, and upload it to Google Drive using this rclone utility. The nice thing about this utility is it's written in Rust, or no, it's in Go, so the Golang. So it's statically compiled, so it can run on any decent decently new uh, system, Windows system, obviously. So they can just drop the binary and be done with the all the um, all the exfiltration process. Pretty nice. They are still operating, and but I cannot find any more evidence of their infection, like the first stages of infection. I don't know. Well, you see some examples how to use cloud services. Let's talk a little bit about pros and cons about this approach, and it will be from the attacker viewpoint because it's kind of easier to think in that way. So the big plus is obviously that most of them are free or almost free, quite easy to set up, and you need just a couple clicks to be to have a working hosting or disk storage or whatever you need. Mm, they are most of the time easily scriptable because that's how they are designed, and so you have either quite easy. It's quite easy to create automated way to analyze your assets or have keep tabs on your assets. In this case, would be for example bots, new bots. Um, from outsider, its point of view, it's kind of hard to figure it out if the link belongs to attacker or not. So if it's a good link or not. Uh, for example, you see the links from Dropbox. There is no way of knowing who the owner is, what the file is, unless and until you access it. In case of Google Drive, you get the same, more or less similar file structure, but you can get some metadata, which we'll be talking about later on in a few minutes. And if you use open source malware, you can kiss code attribution goodbye, obviously, and it's actually hard to get the provider to take down an account or files that they're hosting. Uh, with actually notable exception of Heroku, which I worked pretty closely with. They get concerned about phishing elephant using their infrastructure, so they managed to create some scripts and some signatures to find out their activities and later on kick them out from the infrastructure, which was a nice surprise. And obviously, if there are pluses, there are minuses, and the minuses for the attacker is if the researcher know where to look, most of those services leaves a lot of metadata, quite a lot of metadata. For example, Google Drive will give you email addresses with the IDs of the account that create the files, but also timestamps of creation and modification. So that gives you some ideas of time frame of an attack. And but the biggest problem is that API, some sort of API keys or encryption keys or whatever, some sort of keys are needed for accessing those resources. And if you don't know how to properly secure them or configure them, you'll give sorry, you'll give a lot of access to researchers to the data that they should not see. For example, you can see all of C2 or take down or remove all the C2 if you didn't secure give proper access rights to the API keys you're embedding in them into malware. And as I said, the cloud operators have a little bit different visibility than your typical hosters. So if you buy a dedicated software, uh, you're basically done with it, right? Anything that all of the things that can be done by the hoster is basically remove your account, clean your machine. But the cloud providers can, like if they're doing some SaaS or PaaS services, they can monitor what you're doing or other things that they have insight into. But so the insight is quite unique, and that can be used for good in terms of finding the bad guys. Hey, that's all from me. Thank you very much. Hope you guys enjoyed at least a little bit. If you have any questions, I'm here to answer them. If not, if you don't want to do it publicly, send me an email, contact me on Twitter, wherever you want. Thank you very much, and goodbye.